Chapter 2, Section 1, Writing and Graphing Inequalities. Raise your hand if you can tell me something you know about inequalities. Raise your hand. Yeah.
They have numbers.
Yeah, they can have numbers in them, yes. What else?
Oh, never mind.
Do we know what the inequality symbols are?
Oh, yes.
Greater than. So, what does greater than look like? Show me in the air. What? Like
Like this, look.
this? That's greater than. Right? What is this?
Less than.
It's less than.
Wait till it pops up on the board. There we go.
Less than or greater than or equal to.
Just like
Okay,
this.
so greater than or equal to, right? And then we have less than. Looks like that. And less than or equal to. We all okay with that?
Yep.
We've all seen the inequality symbols before, correct?
Yes.
Okay. Anyone else know anything else about inequalities?
The greater number always wins.
What do you mean always wins?
Like the little alligator mouth.
Yeah, the alligator mouth.
Eats the bigger number.
Always eats the bigger number or bigger expression, right? So it's pointed to if the mouth is pointing to the left side's bigger, so it's the left side is greater than the right side. The mouth is pointing to the right, the left side would be less than the right side because it's still eating the bigger thing, right?
Yes.
That's an easy way to remember it.
We don't got.
Come on, any moment now. There we go. An inequality is a mathematical sentence that compares expressions. An inequality contains the symbols that we just talked about.
Thank you.
Less than, greater than, less than or equal to, or greater than or equal to. To write an inequality, look for the following phrases to determine what inequality symbol to use. If I were you guys, I would definitely have this chart right here written down. Those are some key phrases you will see on your assignment. You need to know which symbol to use whenever those key phrases are used. The first two are pretty simple. It's less than and greater than. The key phrases for those is less than, is fewer than for less than. Those all make sense, right? This side is less than that side. This side is fewer than that side. Same thing with greater than. Is greater than and is more than. Did someone have a question?
I was just asking if you can, like, you give us some time to write the definition and then write.
Yeah, I'm giving you some time. When we get to the or equal to symbols, that's when they can kind of get a little confusing. Let's look at the key phrases under is less than or equal to. Of course, it says less than or equal to. Whenever we get to these bottom two, is at most and is no more than, people get confused. They associate the words most and more than with it being a greater than symbol. But is that the case? No. If something is at most something, can it be bigger than that?
Yes.
If it's at most, can it be bigger than that
It's only
thing?
be at most.
Yeah, it's at most that thing, so it has to be less than or equal to that thing. Does that make sense?
Yeah.
Same thing. Is no more than. If it's no more than something, can it be more than it?
Nope.
No, it's got to be less than or equal to. So don't associate these words with greater than. These phrases mean less than or equal to. Okay? Same thing with greater than or equal to. Is greater than or equal to? Is at least, is no less than. People associate the words least and less with less than. Don't do that in this case. If something is at least something, can it go smaller than it? No, it's got to be greater than or equal to that. If something is no less than something, can it be less than that thing? No, it's got to be greater than or equal to. Okay? So definitely have this chart written down. It'll help you out on your assignment today. You will see some of these phrases in your assignment. Everyone got that?
Yep.
All right.
Okay, I'm going to give you a little time to write this down. Moving on. Example 1, writing inequalities. Write each sentence as an inequality. So it gives us 3 sentences. We need to convert those to write them as an inequality. So letter A. I've got a number W minus 3.5 is less than or equal to negative 2. Raise your hand if you can help me out and write this inequality for me. Here you go. Write it on the iPad for me next day. Okay. Number W minus 3.5 is less than or equal to
W.
negative 2.
3 point. It won't do a point.
You gotta kind of scribble it on. There you go.
Okay. 5 is
Does everyone agree with that?
Wait, what?
Nah, it's close. What are we missing? A minus sign. It's number W
Oh.
minus 3.5, right? Everyone agree with that?
Minus 3.5 is less than or equal to negative. Oh, that makes
Everyone agree with that now?
Yes.
So our W minus 3.5 is less than or equal to negative 2. Everyone see where we're getting that from? Okay. Letter B. 3 is less than a number n plus 5.
Wait.
Yeah. Question on A?
Yeah. Wait, can you compare it to? I have one. Did I switch these around? Oh yeah, I switched them around. That's why I was confused.
Okay. Raise your hand if you can help me out on letter B here. 3 is less than a number n plus 5. Don't drop it.
So it's
Three is less than is it
Everyone agree with that?
no.
What's wrong here?
It's not less.
It's
It's
not
not
less than
less than or equal to, which is less.
Very good.
oh so I was
You're close.
You're close, but it's okay. You learn.
Now do we agree on it?
Yes.
Good. 3 is less than a number n plus 5. Are we okay with that?
Yes.
Are we okay with A and B? Any questions so far?
JTV class.
Letter C. 0 is greater than or equal to twice a number x plus 1. Raise your hand if you can help me out here.
Well, yeah, outside.
0 is greater than or equal to twice the number x plus 1.
Oh, that was like a 7.
It's okay. We know what you mean.
Yeah, equal to. Alright. That was like a 7.
Do we agree with that?
No.
What's wrong?
He didn't add two by the X.
Good. So how should it look?
X 2x plus 1.
There we go. There we go. 0 is greater than or equal to twice a number x. So that'd be 2 times x plus 1. Does that make sense?
Yep.
Questions on C? On your assignment, you will see some problems like this. Your assignment will throw some of those other key words at you, those key phrases. Is no more than. Is at least. It'll throw those phrases in there, so you need to make sure you have that chart written down so you can know which inequality symbols to use. Questions on example 1? A, B, or C? Okay, move on.
Wait.
Okay, go ahead and move on now. Okay, let's talk about solutions of inequalities. A solution of an inequality is a value that makes the inequality true. Remember when we were dealing with equations, how did we check a solution of our equation? Plugged it back into our original problem. If it gave us a true statement, it was a solution, right? Same thing here. If I'm testing a number to see if it's a solution of my inequality, plug it in, work down both sides of the inequality. Gives you a true statement, it is a solution. If it gives you a false statement, it's not a solution. Does that make sense? Still the same concept. You should have inequality symbols instead of equal signs now. An inequality can have more than one solution. How many solutions did most of our equations have? One, right? Our variable equals some number. Most of the time. Absolute value had 2. Sometimes we'd have no solution. Sometimes we would have infinitely many. But most of the time we would just have 1, correct?
Mm-hmm.
That's not the case with our inequalities. Our inequalities, the solutions will be written something like this. This would be a solution of some inequalities. X is greater than 3. How many numbers are greater than 3?
2. No. Oh, whoa.
An infinite amount of numbers, right?
My bad.
Do the numbers ever stop going greater than 3? No. So there's an infinite amount of numbers that are greater than 3. So there's an infinite amount of numbers that are solutions to this inequality. Does that make sense? There's not just one set number that's a solution. We just use the inequality to represent the solutions, and we'll use graphs to represent the solutions as well. Does that make sense? Okay. So in this little chart here, they gave you an inequality, and they're testing numbers to see if they are solutions. So they plug -6 into x plus 5 is greater than or equal to -2. So I plug it in for x, and now we just work down both sides of the inequality. What's -6 plus 5? -1. Is there any more simplifying to do on either side? No. So I got to look at the statement that I have. Is -1 greater than or equal to -2?
Yes.
Yes. So this is a true statement. So -6 is a solution of that inequality. Does that make sense? If you plug it in, you get a true statement. It's a solution. Yeah.
So it'll give you the value of x, and you guys see if it's true or not?
Yeah, we're about to do some examples on our own.
Oh.
Okay. They plugged in -7. -7 plus 5 is? -2. Is -2 greater than or equal to -2?
Yes.
Yes. Remember, for inequalities, it has to fit one of the conditions, not both of them at the same time. It has to either be greater than or equal to. So -2 is equal to -2, so it fits one of my conditions, so it is true. -7 is a solution. Does that make sense? Okay, they plug in -8. -8 plus 5 is? -3. Is -3 greater than or equal to -2? No. That's why they have a slash through the greater than or equal to. That's what this paragraph at the bottom is talking about. Just like if I have a slash through an equal sign, that means it's not equal to, right?
Yes.
This is saying -3 is not greater than or equal to -2. So since it gave me a false statement, -8 is not a solution of the inequality. Does that make sense? Are there any questions about anything I just covered on the slide? Okay, let's jump into some examples that are similar to it. Inequality gives us inequalities, gives us a value of x of -4, and it wants me to check to see if -4 is a solution. So letter A. I get x plus 8 is less than -3. How am I going to check to see if -4 is a solution? Yeah, plug -4 in for x. Everyone okay with how I plugged in? Take the variable out, put -4 in its place. Now I'm just using my order of operations to work down both sides of the inequality. What's -4 plus 8? 4. Is there any more simplifying to do on either side here? No. So now I've got to look at the statement that it gives me. 4 is less than -3. Is that true or false?
False.
False. 4 is not less than -3, is it?
No.
So is -4 a solution?
No.
No. So I'd say -4 is not a solution. Hold on. I'm about to answer your question. I know you're going to ask it. Do not put no solution. Do not do that. Oh, okay. Well, don't do this anyways. There is a solution to this inequality. I'm just saying negative 4 is not a solution. Does that make sense? What was your question? Just write negative 4 is not a solution. That's not that long. You can write it out. You'll be fine. Yeah, that works. If you want to say negative 4 isn't a solution, that's fine. Questions on A? Do we understand that concept? Okay, letter B. Negative 4.5x is greater than negative 21. How am I checking to see if negative 4 is a solution or not? Plug negative 4 in for x. What's the operation going on between negative 4.5 and x? Multiplication. So when I plug in negative 4, I got to make sure it's being multiplied by negative 4.5. Negative 4.5 times negative 4 gives me 18. Can I do any more simplifying on either side? What? No. So let's look at the statement. 18 is greater than negative 21. Is that true or false? True. So is negative 4 a solution here?
Yes.
Yeah, so you'd say negative 4 is a solution. And you're done. Any questions on that? Yep.
So, what if you do have to move after that? Like, you just, like, work it down?
Yeah, use your order of operations to work down. These just had one step each on the left-hand side. So we just did one step and we were done. You might have to multiply and then add, or do grouping symbols and then multiply. So just go through your order of operations. Okay? Questions on example 2? Okay. I think you guys have seen graphs of inequalities before. The graph of an inequality shows the solution set of the inequality on a number line. So it's just another way to represent our inequality, is the graph. You guys probably remember this the most, is the open circle, closed circle, right? How do I know if I have an open circle?
If it's going to the right.
Open circle.
Oh.
If it doesn't have a line.
Yeah, there's no line underneath the symbol. It's got an open circle. How do I know if it's a closed circle?
It has a line.
It's got a line under it. It's a closed circle. You guys remember that? Same thing here. Same thing you learned last year, whenever it was. An open circle, there's our open circle, is used when a number is not a solution. So the solution set goes all the way to that number, but that number is not included in the solution. We use an open circle. A closed circle is used when a number is a solution. So my solution set goes all the way up to that number, and that number is included in the solution set. An arrow to the left or right shows that the graph continues in that direction. So I will have to shade my graphs as well. On a number line. Any questions? Okay, let's get into it.
Oh, wait.
Okay, I'm waiting. I'm sorry. Okay, let's graph. Graph each inequality. Letter A, y is less than or equal to negative 3. Got to draw my own number line. Y is less than or equal to negative 3. First off, let me ask this question. What number is my circle going to go on? Negative 3, because that's part of my inequality, right? Okay. Is it going to be an open or closed circle on negative 3?
Close.
How do I know it's closed?
To the line.
It's got a line under it. It's less than or equal to negative 3. So I'm going to put a closed circle on negative 3 on my number line. We okay with that? We okay identifying what number to put the circle on and if it's open or closed?
So if there's
Yep, no line under it, it's open. Now I've got to shade my graph to finish representing all my solutions. I want all numbers that are less than -3. Numbers that are less than -3 are those to the left of -3 or to the right of -3 on a number line?
Left.
To the left, so which way am I shading?
Left.
To the left, very good. So I'm shading to the left of -3. There's my graph of my inequality.
Like, we just like make our arrow darker. Is that easy?
I want you to shade it. That way I can for sure tell which way you're shading. Okay? Any questions on letter A? So, this graph is representing all the solutions of this inequality. If that number is in the shaded region, it is a solution. If it's not in the shaded region, it's not a solution. So let me ask you this. Would -20 be a solution of this inequality? Yes, because it would fall in the shaded region, right? Because that arrow means it goes on forever and ever and ever in that direction. Also, -20 is less than or equal to -3, right? Okay, is +20 a solution here?
No.
No, it's not in my shaded region. It's in that unshaded region. Is -3 a solution here? How do I know -3 is?
It's less than or equal to.
It's less than or equal to. It's got a line under it. Also, it's got a closed dot on it. The closed dot means that it is a solution. Does that make sense? Question.
Oh, never mind.
Did I answer it?
Yeah.
Okay, perfect. Questions on A? Okay, letter B. 2 is less than x. I draw my number line. There's my number line. 2 is less than x. What number is my circle going on? 2, because it's part of my inequality, right? Is it an open or closed circle on 2? Open. There's no line underneath my inequality symbol, is there? So I put an open circle, an open dot on 2. And then which way am I shading?
To left.
To the left? Who says to the left? Who says to the right? Why are we saying to the right and not to the left?
Because it has to be greater than 2 in that way.
Very good. We got to read it from our variable standpoint.
Oh.
From our variable standpoint, it says x is greater than 2, correct? Are numbers that are greater than 2 to the right or to the left of 2?
Right.
To the right. So I've got to shade to the right of 2. I don't want y'all to get in the habit of shading just whichever way the arrow is pointing. Okay? And this is exactly why. There's my graph of B. So would 152 be a solution of this inequality?
Yes.
Yes, it would. Would negative 737 be a solution?
No.
No, it's not in the shaded region. Would 1.5 be a solution?
Yes.
No.
No. It's less than.
No, 1.5 is not in my shaded region, is it? Would 2 be a solution?
Yes.
Are you sure?
No.
Why is it not a solution?
How to be greater.
It's not or equal to. It's an open circle. So my interval, my set notation, my solution set goes all the way to 2, but 2 is not a solution. So like 2.1 is a solution. 2.0000000000001 is a solution because that's greater than 2, right? But 2 itself is not a solution. So the solution set bumps all the way up to next to 2, but 2 itself is not a solution. Questions on B? Okay, last one on this slide, letter C. We've got x is greater than 0. There's my number line. What number is my circle going on? What? 0. Is it an open or closed circle on 0?
Open.
Open. There's no line underneath my inequality symbol. Open circle is 0. Okay, it says x is greater than 0. Numbers that are greater than 0, is that to the right or to the left of 0?
Right.
Right, so I need to shade to the right. We all understanding how to graph here? So there's my graph of x is greater than 0. Is negative 2.75 a solution here? No. It's not greater than 0. It's not in my shaded region. Would 10.2 be a solution here?
Yes.
Yeah. It's greater than 0. It's in my shaded region. Is 0.000000001 a solution here?
Yes.
Yeah. It's in my shaded region. Is negative 0.0000001 a solution? No.
No.
Is 0 a solution?
No.
No. It's got that open circle on it. It's not or equal to, so 0 is not a solution. Are we understanding what numbers are solutions, what numbers are not solutions? Okay, let's move on. Example 4. Writing inequalities from graphs. So the previous slide, we were given an inequality. We had to graph it. Here we're given a graph. We need to write an inequality. Inches for 2 rides at an amusement park. Write an inequality that represents the height restriction of each ride. So like I said, we're given a graph. We need to write an inequality from the graph. So ride A. What are the height restrictions on ride A just based on the graph? 48 inches or taller. You can ride the ride, right? Everyone agree with that? Okay. If your problem does not give you a variable, you're able to pick your own variable. Are we given a variable here?
Yes.
Yeah, we're given h, so we've got to use h. Okay? So I know h is going to be a part of my inequality. On ride A, what number is my circle on?
48.
48. So 48 is going to be the other side of my inequality. We agree with that?
Yes, sir.
Okay. Is this shaded to the right or left of 48? To the right. Is that numbers that are bigger or smaller than 48? Bigger. So what inequality symbol do I have to use? Greater than. Last part here. Is it an open or closed circle?
Open.
Closed on 48. So do I get a line under it or no?
Yes, you yes.
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 There it is. And let's go ahead and put inches, since that's what we're talking about. So h is greater than or equal to 48 inches. There's my inequality for ride A. Does everyone see how we built that? Any questions on it? Okay. Ride B. Just looking at the graph, what are my height restrictions here?
52 and lower.
Are you sure it's 52 inches or shorter? Yeah, it's just everything less than 52 inches. Is 52 included?
No.
No, so I can't say 52 inches or shorter, can I?
No.
It's just less than 52 inches, right? So what's our variable again?
H.
H. What number is the circle on? 52. Is this being shaded to the left or right of 52?
Left.
Left. So is that numbers that are less than 52 or greater than?
Less.
Less than. So I'll use the less than symbol. Open or closed dot? Open. So do I get a line or no line?
No line.
No line. Let's go ahead and use inches. So h is less than 52 inches. Represents the height restrictions, height requirements for ride B. Questions on that? I think I could ride B.
I don't think Buddha could.
Any questions on example 4?
Can I finish writing this down
Really
really fast?
fast. Really fast. Running out of time here. This one is also in the textbook. I'll actually come back to this slide if I need to. I'm going to go ahead and move on real quick. This next slide just represents or shows all the ways to represent a linear inequality. You don't necessarily have to write it down. It's in the book. But we can use words, sentences to represent inequalities, algebraic expressions to represent inequalities, and graphs. So are there any questions about any of the ways to represent an inequality? Okay, here you go. Here's the assignment. Pages 64 and 65, 6 through 46 evens. This will be due Friday, the 16th, on Canvas. It's about 21-ish problems, which is a little more than usual, but most of these problems go a lot faster than our usual problems. So that's why I gave you a little more. Yeah. Just go ahead and write it down. Okay? Make sure you get the correct heading on your paper. Name, date, period, assignment in the upper right-hand corner of your piece of notebook paper. Your assignment is what's boxed in up here. Pages 64 through 65, 6 through 46 evens. I'll probably call this on Canvas 2.1, homework number 1.
Can I take a picture of that?
Yeah, if you need to take a picture of the textbook pages in your book, you can do that, or you can access the book online on your computer at home. Are there any questions before I end my recording?